All right, guys. So in the last video, I talked about right briefly at the end about the information that we're given and what we're solving for. And let's just take a look at just picking two of these parts to make one proportion. And in both problems that I've done with you before, I've given you two angles and one side. So like for example, I've given you angle A, angle B, and side B. And where are those in our diagram? Let me circle those as well. We've got angle A, angle B, and side B. Okay. Now, thinking back to our geometry days, we used three-letter abbreviations to talk about the information that we were given in a triangle. This would correspond to angle, angle, side. Right? Okay, if you recall, angle, angle, side, we have two angles in the non-included side. Side B is not between the two angles. So that is one possibility that we have solved using the law of sines. Okay. Well, let's look at another scenario here. Let's see here. How can I erase this stuff? Here, this is just what we'll do. Okay. So let me just make that note over here. Angle, angle, side. Okay. Now let's look at another scenario where I gave you this angle, and that side. What does that look like? Okay, so we've got this side, this angle, that angle, and again we have angle, angle, side. Cool. Okay. Let's pick another pair. Let's say I gave you this angle, and this side. What do we have now? Angle A, angle C, side C, and again it's angle, angle, side. So we see that coming up over and over again. However, I give it to you where you have two angles, one side. Now, let's pick some different information. What if I gave you this side, and this angle? So let's see here. This side, that angle. What do we call that? Well, that is side, angle. Okay. And what that should ring a bell for you guys in geometry, that's a big red flag, right? Side angle, we can't do side angle. If we spelled it backwards, it would say a naughty word. Okay, we remember that side angle did not guarantee a unique triangle. Okay, right? Where we had all these different ways of proving true triangles are congruent, but side angle did not was not the information that we needed to guarantee that there was one unique triangle. Okay, and let's head to GeoGebra here for a second to look at side angle some more. All right, so what I have set up here is I have a line here, and this is going to be a side of the triangle, but I don't know how long that's going to be yet. I have this angle at angle A, which I'm not going to change, so that's our angle. I have this side length, which I'm not going to change as well, so there's a side. And now I'm going to make another side length of a certain length, and we're going to see what happens. So what I'm actually going to do with that is I'm going to use a circle. Okay. And I'm going to make my circle something like this. Okay. Now here's what I want you to notice. Okay. So I have an angle there, I have a side here, and I have a side there. How many triangles can I make with this angle measure, that side length, and this side length? Well, I can make this triangle right here. Okay. Angle, side, side makes this triangle. But I could also make this triangle right here. It has the same angle and the same two side lengths as this triangle. See this triangle? Angle, side, side. This has the same angle side to side, and there are two possible triangles. Okay. Now, is it possible that with side-side angle that we could have just one possible triangle? And the answer to that is yes, it is. If we go like this, there is only one possible triangle. Okay. In this case, it's a right triangle. Okay. This angle, this side, that's the only triangle we can make with those two side lengths and that angle. Okay. Is there another way we could do it? Yes, there is. If I go like this, angle, side, side is only one possible triangle because the other place the circle intersects the line on the bottom is over here, and we're no longer using this angle. We're using its supplement angle over here instead. So in this case, there is only one possible triangle. Is it possible that we could have no triangles with a side, side, and angle? And the answer to that is yes, it could look like this. So how do I want to break it down? Well, we're calling side, side angle the ambiguous case. Ambiguous means not very clear. Okay, we're not sure what's going on. So we have to really think about what could happen. It is possible that side, side angle could make 0 triangles. It's possible that it could make 1 triangle, and it's possible that it could make 2 triangles. All right? So how are we going to break this down? Let's go back to GeoGebra here again. Okay. Okay, take a look at how I set this one up. How does the side length CE compare to the side length CA? We can tell that it's bigger, right? It's longer. Notice this side is longer than that. If this side is longer than that side, there's only one possible triangle. Okay. When this side is shorter than the other side, it's possible that there's 2 triangles. It's possible that there's exactly 1 triangle, or it's possible that there are no triangles. Okay. So what I call these is I call these big side, little side angle. I use a big S for big side, a little s for little side, and angle, obvious A for angle, obviously. And those are some goofy looking S's. Let me see if I can draw that again. Big side, little side, angle. Or we could have little side, big side, angle. And what do these produce? Well, we saw that when it was big side, little side angle, that's our one possible triangle. We like big side, little side angle because there's only one triangle. If this side's longer than that one, the longer than the side that's next to the angle, there's only one possible triangle. Now, why did I write a B? I'm sorry, I'm sure you guys were confused there for a few moments. If I have little side, big side angle, that's this case where there might be 2 triangles, 1 triangle, or no triangles. This is the dangerous one. Big side, little side angle, that one's easy. But little side, big side angle, this is the one that's dangerous, that we have to be careful. It is possible that there's 2, 1, or 0 possible triangles. Okay. So we have to be really careful with that. So we have to pay special attention to when we have side-side angle, which is the bigger side? Is it the side opposite? Yeah. Is it the side opposite our angle, right? So here's my angle. This is the side opposite it. If the side opposite of the angle is the bigger one, that's big side, little side angle. Okay. If the side adjacent to the angle we know is bigger, then that's little side, big side angle, which is the dangerous one. All right, so let's look at this. Find A given angle B is 23 degrees, side A is 8, and side B is 6. So let's draw this one out. Okay, so let's label this here. I made this the smallest angle, so I'm going to call that angle B. So I'll call this angle A, this angle C. Let's see here. So side A is 8, side B is 6. All right. So what do I notice about this? First off, I notice this is side-side angle. I have two sides and the non-included angle, side-side angle. So then my next question becomes, is it big side, little side angle or little side, big side angle? And when I take a look at it, the smaller side is opposite the angle that we have. This is little side, then the big side, then the angle. Okay? So this is the danger zone. Okay, this is where there could be 2, 1, or 0 possible triangles. We have to be super careful. So let's set it up with the law of sines and let's see how we're going to handle that. Let's see what happens. Okay, notice I know side B and angle B. We want side C. We need to find angles A and C. So I'm going to take what I know here and set that up first. So I'm going to take B over the sine of angle B equals, well, what am I going to solve for next? Can I solve for side C next? No, I can't, because I have to know angle C in the law of sines if I'm going to solve for that. So let's solve for angle A next. So we're going to do side A over the sine of angle A. Now, how are we going to solve this? Using a little cross products, cross multiply and divide, however you want to think about it. We have the sine of angle A equals 8 times the sine of 23 degrees over 6. In other words, the sine of angle A equals 4 times the sine of 23 degrees over 3 when I just reduce the 8 over 6. So I use cross products here. 8 times the sine of 23 degrees over 6 equals the sine of A. Now, how do we solve this for A? Well, we have to take the arc sine of this to find A, right? The arc sine is the inverse, so it's going to remove that. A equals the arc sine of 4 times the sine of 23 degrees over 3. And it's time to put that in my calculator. So I'm going to go arc sine 4 sine of 23 degrees over 3. And here's what I get. 31.4 degrees. So now my question is, how do I know if there's 2, 1, or 0 possible triangles? Well, let's label this in. We just found this to be 31.4 degrees. What is angle C then? Well, if I take 180 minus 23 minus 31.4, I get 125.6. It appears that there certainly is one possible triangle, but could there be two? Right? Now, if these angles didn't work out, then there would be 0 possible triangles. So now we have to think back to arc sine here for a second. Okay. And think about how we find arc sine. Okay. And what part of the unit circle arc sine resides in. Well, we found that 31.4 degrees is the one value. Well, where else, okay, what other angle measure would have the same value for sine? Now, here's what I noticed. Now, we said arc sine is on the right half. However, we're not going to use a negative angle for the value of sine. We're going to just come right over here. This angle also would produce a sine value that's the same as 31.4 degrees. Okay, they have the same y value. So what is that angle? Looking at my clock, I'm going to run out of time, so I'll go into the next video.